Continuing with the idea of inequalities, we're going to talk about rational inequalities today. A rational number is any number that can be written as a fraction where the denominator is not equal to 0. So when we look at rational inequalities, we have fractions. We are going to need to be able to deal with fractions. There's a problem oftentimes where students try to get rid of the denominators, and unfortunately what that creates is a situation where you eliminate some of your critical values, and so we don't want to do that. So what we're going to do, I'm going to zoom in here on problem number 1, okay, give myself some space. What I want to do is to get one side of this problem equal to 0. And the easiest way I'm going to do that is to subtract 2 from both sides. All right, so we've got t minus 1 over t minus 5 minus 2 is less than or equal to 0. Okay. Now, if it's been a while since you've worked with fractions, all right, we need to combine this. But in order to combine these, we need a common denominator. So the common denominator here is going to be t minus 5. And we need to do that, multiply that to the numerator as well. So if we do a little cleanup here, we've got t minus 1 over t minus 5. I'm going to go ahead and distribute this negative 2 to what I was multiplying across the numerator there. So because I'm distributing the negative, there is actually going to become a plus sign between those two fractions now. So negative 2t plus 10 all over t minus 5. All right, now that my two fractions have a common denominator, I can combine them. So that means I am going to be able to combine this numerator with this numerator. All right, so look for your like terms. T plus negative 2t would be negative t. Negative 1 plus 10 would be positive 9, all over t minus 5. And at some point I lost the inequality sign here. Sorry about that. Okay. So we're looking for our critical values. One of our critical values is going to come from the numerator. We are going to set the numerator equal to 0 and solve it. So this is going to turn into t is equal to 9. Okay. So that's one of our critical values. The other critical value is the one that comes from the denominator. Not that the denominator is going to make this thing equal to 0, but the critical value from the denominator creates that value that we have to throw out of the domain. And so separately, we would have t minus 5. Go ahead and set that equal to 0. It's a critical value here, so we're going to say t is equal to 5. All right. So all of this work, okay, and what I'm looking for next is going to be my number line. All right. So on my number line, I'm going to go ahead and put my two critical values. I've got 5 here, I've got 9 here. Okay. And we're going to do the same thing that we did with the quadratics, where we're going to test. All right, just test something that is not the critical values. So it's easy enough to test 1, or I don't know why I just said 1 when I wrote a 0. Sure, it's easy to test 1 as well. I'm going to go ahead and test 0. I'm also going to test 6, and I'm going to test 10. Again, anything is fine. Anything's fair game. You could test, 7.2367, whatever. You could test 3 million, and you could test negative 2 billion. All right, it doesn't matter as far as your numbers go. The only thing that's going to matter is just make sure you can put it in your calculator. All right. Let's see how much space I have here. Ooh, I got plenty of space. Awesome. All right. So if I'm going to test 0. All right, that test goes all the way back to the original, okay, all the way back. So we would have 0 minus 1 over 0 minus 5 is less than or equal to 2. So let's see, this left side turns into 1/5 is less than 2. Sure enough, 1/5 is less than 2. So that means I'm going to shade all those values less than 5. Okay. If I test 6, so I've got, 6 minus 1 over 6 minus 5. So what would that be? That would be 5 over 1. So I have the statement that 5 is less than or equal to 2. No, it's not. That is a false statement. Okay. And really quickly, just so you know what just happened, that was for the original one. That's true. Okay. And so we're not going to shade anything between 5 and 9 because that test value of 6 did not work. Let's go ahead and test 10. So 10 minus 1 over 10 minus 5, less than or equal to 2. All right, so 10 minus 1 would be 9. Okay, 9 over 10 minus 5 is 5. So 9 divided by 5 is 1.8, just for reference. Okay, so yes, 1.8 would be less than 2. That is a true statement, which means I'm going to go ahead and shade everything greater than 9. Okay, now parentheses, brackets, what do I need? So the inequality that I kept writing throughout this problem had an equal to. So the critical value that came from my numerator is going to take that bracket, the equal to part. However, the critical value that came from the denominator cannot be equal to 0. Okay, if I put 5 in this original problem back here, right, 5 minus 5 is 0. You cannot talk to me about a fraction that's undefined. You can't say, well, undefined is less than 2. That does not have mathematical meaning. So t can be all the numbers up to 5, but it can't be 5 itself, so we're going to use a parentheses there. So please be careful that you recognize which one's which. All right, so the critical value from the numerator versus the critical value from the denominator. All right, I'm actually going to put this answer kind of above my number line here. So it started at negative infinity, it went to 5 with a parentheses, union 9 to infinity, and 9 is going to take the bracket. Okay, so these are not the fastest problems, okay, but if you take your time with them, slow yourself down, and really pay attention to what you're doing with your fractions, you should be okay. We're going to go ahead and do problem number 2 next. So problem number 2, I need one side of this problem to equal 0. It's going to be a lot easier to add 1 than it is to probably move that whole other fraction over. So I'm going to go ahead and add 1. All right. Now you'll notice I keep leaving myself this little space here. Part of it's because of years of practice, but I do know I'm going to have to create a common denominator here. All right, so x minus 2. All right, so 4x over x minus 2 plus, distributing 1 does not change anything. So x minus 2 over x minus 2. All right, I'm going to go ahead and combine my two numerators. Okay, so let's see, 5x minus 2 over x minus 2. Now, my numerator is going to give me one critical value. My denominator is going to give me the other critical value. So the critical value from the numerator is going to be 2/5. Critical value from the denominator is 2. Okay. So on my number line, I'm going to have 2/5, and I'm going to have 2. You could definitely test 0. You can test, I test 1 there, and I test 3. All right. So if I test 0, that would be 0 over negative 2, so that's 0. 0 is greater than or equal to negative 1. That is a true statement. 0 is greater than or equal to negative 1. Okay. So we can shade all the way up to our critical value here. Let's see if I can test 1. So let's see what we got here. That would be 4. 1 minus 2 is -1. So 4 over -1 is -4. -4 is greater than -1. That is not true at all. So that tells me the numbers between from 2/5 to 2, none of those values work. I want to test 3 here and see what happens. So let's see, I've got 4 times 3 is 12. 3 minus 2 is 1. 12 over 1 is just 12. 12 is greater than -1. That is a true statement. So I can shade from 2 to infinity. Okay. This particular rational inequality did have an equal to. So the critical value that came from the numerator, in this case 2/5, takes the bracket. The critical value that came from the denominator, not so much. Parentheses there. All right. So obviously you're noticing I did not write out the check for this one. You don't have to write the check out. You just have to be able to do it so that you can find where the shading is on the interval. Okay. Most of the time, your intervals will alternate. So one will work, one will not, one will work. Here's the problem with that. It doesn't always work. And so you'll notice I will always test all the intervals because I don't have a good way of telling you, oh, in this instance, these 2 intervals that are in a row, you would use both of them. I don't have that for you. All right, so problem number 2 is all done. Let's move on to the last one for this particular video, number 3. And this is just in all kinds of a special treasure here. All right. So we're going to have 2 over r plus 3. I'm going to move this entire fraction to the other side. So minus 6 over r minus 1 greater than or equal to 0. I need a common denominator. So common denominator here is going to be r plus 3, r minus 1. Okay, so this first fraction was missing r minus 1. So we're going to do 2 times r minus 1 minus 6 times the second fraction. I pulled the minus 6 already, but this denominator was missing r plus 3. Okay. So I know I've just done a bunch of stuff at once, but what just ended up happening is I created my common denominator using the 2 denominators I was given. So r plus 3 and r minus 1. At the same time, I'm rewriting it as a single fraction. So this numerator of 2 needed an extra r minus 1 to create the common denominator. This numerator of -6 needed the r plus 3 to create the extra denominator. Okay. So little multiplication here, 2r minus 2 minus 6r minus 18 all over. Leave your denominator in factored form, please. It's going to make life easier when you need to get some critical values. Okay, numerator, -4r minus 20 all over r plus 3, r minus 1. Okay. Every factor in this problem is going to give you a critical value. So your numerator, and I'm going to go ahead and put this off to the right side. I have plenty of space over here. So your numerator here, -4r minus 20, is going to give you 1 critical value. So I'm going to set that equal to 0. Each factor in the denominator is going to give you a critical value. Okay. So the 2 denominator ones are going to be pretty easy. R is equal to -3, R is equal to 1. All right. If I add 20, divide by -4, R is equal to -5. So I have 3 critical values. So on to my number line they go. I'm not going to worry about them being perfectly spaced out. I just give myself that space to add those extra, like what critical values am I testing? So I'm going to test -6 I'm going to test -4. I am definitely going to test 0. I always like testing 0. And I'm going to test 2. You are testing always back in the original, okay? And I'm just going to tell you what ends up happening. So your first one, -6 does work. It makes a true statement when you test it. So we're going to go ahead and shade all of those values less than -5. If we test the interval between -5 and -3 with using the value of -4, it does not work. 0 does work. So I'm going to shade between 3 and 1. And the value of 2 does not work. All right. So this particular problem, this inequality the whole way through, had the equal to component to it. However, that equal to component only applies to the critical value from the numerator. That's the -5. So -5 is going to take the bracket, okay? But -3 and +1, because they came from the denominator, they're critical values, but they can't actually equal 0. All right? So using our number line here, I'm going to write my interval out, -∞ to -5, bracket, union with -3 to 1, parentheses on both of those. All right, at this point, I'm going to go ahead and cut this video. I'm sure it is long enough as it is. I will make a secondary video for the next 3 problems in the rational functions, and then I will also post the key for all of the inequalities that we've been doing, so you can reference the key as needed for these problems. All right, send me any questions if you've got them.